Hello, sir. Am I audible?
Yes, I can hear you now.
Okay.
Is my sound and everything clear, or do you want me to?
No, sir.
Good morning, Dr. Gaurav. You are absolutely clear,
Perfect.
and we are very happy to see you.
Yeah, I'm glad to be here as well, and excited to talk. It couldn't be more exciting to talk about sensors right before going to bed. So,
Oh yeah, exactly. Yeah. So that's what I was going to say. That in you are in the you'll be going to sleep now, and we are up. The sun is up
I
this
mean,
side.
yeah, usually I go to bed like later until like not until midnight, so it's totally fine for me. This
Okay,
time
good for.
works perfectly. Yeah.
Okay, nice. So this session will be attended by our faculty members and all our students who are doing the MCA 2 years program, postgraduate
Okay.
program, Masters in Computer Applications. And
Okay.
as an institution, we have been working in the domains of healthcare and agriculture for the last
Okay.
4-5 years. We are happy that we have been associated with GIST and Yellowji sir. So through him, we got good contacts. We are
Yeah,
happy
it
to
was
have.
really good to see all the, sponsors and affiliations that was highlighted in the group. So, and also good to know that the connections with agriculture and natural resources. So, yeah, I'm looking forward to it as well.
Right. So, Dr. Padma, you will be taking it up now, ahead now. Dr. Padma.
Yes, ma'am. I'm starting with the session now.
Okay,
So I will
fine.
give the introduction about our guest. Yeah. Okay.
Also, I had a question about like the time. Do you want me to keep it like 20, 25 minutes? And like I saw it was 30 minutes. Like
Yes, sir. It is 30 minutes.
It's fine for 30 minutes. And then after 30 minutes, if there are any questions from the side of the faculty or the students, then we can have it.
Okay. That sounds great. I just want to make sure I don't talk too much because I'm a chatty person and it could just go a lot longer. So I'll make sure.
Yeah. Okay. Yes, sir. I welcome you all for pre-conference session of Icaim 2023 on behalf of Thakur Institute of Management Studies, Career Development and Research. Today, our speaker is Dr. Gaurav Jha for the pre-conference session on topic sensor technology for curbing global warming. Sir, now I'm going to play the introductory video about yourself. Shall I, sir?
Yeah, go ahead. Sure.
Sir, now I hope you like the introductory video.
That was very cool. That was interesting. Gathered all the information there. Thank you.
Okay. Thank you, sir. Now I would like to request you to proceed with the session, sir. Sir, I would like to request you to proceed with the session, sir. Yeah.
All right. I'll first share the screen and make sure everything is visible.
Yes.
Are you able to see the screen?
Yes, sir. It is
Okay.
visible.
Great. Just give me 1 second. And feel free to interrupt if anything is not audible or if I'm not making any sense. I'm happy to coordinate about that. And I hope I'm not blocking anything with uh, the Zoom caption or anything on the screen. So, all right. Thank you so much for the wonderful introduction video. That was very good to see my own journey in a musical format. So it's exciting, and I am looking forward to talk about my experiences, is how I envision about sensor technology and how global warming across the planet, and also thinking beyond that, how we could curb the technology. But what my presentation is going to be focused on is soil. I believe farming by soil is the concept given by the leaders of precision farming, is I think niche for any site-specific agriculture or any environmental concerns that we have. So a little bit about myself. My presentation will be starting with the introduction, and then I'll talk about why soil, why you should be considered about soils. I do understand there is a great connections with agriculture and environmental and sustainable aspects of our surroundings here. So I want to highlight a little bit upon the variabilities that we account for soil sciences, and how precision agriculture could help in terms of sensing technologies, proximal sensors, drones, or satellites in addressing some of these challenges. Is it?
अच्छा मग एक काम कर आता उद्या
All right.
पद्माचं टेस्ट सोबत नाही
Please mute Sonu ma'am.
आज पद्माचं मुलांचं speaker Sonu, your speaker is on. Sonu, your speaker is on. Please put it off.
No worries. I hope everything is audible. Sorry, for a minute I thought it's not audible, and feel free to let me know. So I just want to start with the soil-centric approach. Ever since, every time we think about soils, the first thing that at least comes to my mind is how when I started crawling, and how I love the taste of the soil. So especially any household, the biggest fear every mom have is like how soil centric, like how the first thing that a child goes on, takes the soil and into his mouth or her mouth, and then just get used to it. We are surrounded by soils in our life. We have this is something I crave for when I go to India, and that's just because the flavor that the soil brings into my tea, that's amazing. That's something reminds me of home. Picture, it has some cooling properties and other, like a lot of important things in our life. So when I think of soils, there are so many aspects. And again, if I think it could also come down to cosmetics, right? And again, that comes down to clay mineralogy, or how these minerals are integrating, have so many important properties that we extract into our daily lives. So here, I want to highlight a little bit when we look into advertisements for detergent, right? Like we have like soil versus dirt. Like a lot of detergents would focus on dirt. Why do we want to get rid of it? When we use the term soil and when we use the term dirt, we have to be really careful when we are talking to a soil scientist, right? So soil as a niche, the terms has a lot of physics going on, which is soil physics, a lot of hydrology that holds the water, a lot of chemistry that goes on that holds a lot of ions and nutrients that gives nutrition to the plants that grows, and then the food that comes to our plate or feed the livestock as forage that involves all the holding of those nutrients. And finally, the biology that is involved there, with lots and lots of organisms involved in it. So what I want to highlight here, when we use the term soil, it has a lot of action going on, be it physics, soil chemistry, or soil biology, to integrate the process in a holistic system to make the planet more sustainable for food production. But when I call the term dirt, it might just connotate a term that we just want to get rid of. So again, reiterating on the fact, it's a diverse composition of nutrients, a lot of physical compositions, a lot of, so there is basically, when you think about a soil matrix or a soil as a system, it has 50% division of that constitute 20, like water and air. 25% is just a generic number that we kind of go forward with, but it depends on how much water is being filled into the soil pores. Rest constitute the inorganic mineral matter, and also 5% of it is approximately constituted about the organic matter that makes soil is what we have. I like to bring up this analogy. I wish this was more in person, and I would have loved to take a layered cake. And this is what I do when I teach my students here. I have a chocolate layered cake. I try to bake it and have it more like stagnated one over the other, basically connotating the top creamy layer as the soil organic matter, which is the rich layer that holds lots and lots of organic matter. As you go down, it shows how soil has formed over time, how the mineralogy is variable. For example, if I have a mineral called pyrite, which is iron and the composition of iron and sulfide, that means my soil could be acidic in nature because that's bringing kind of iron and aluminum in the soil. So basically, soil is divided into different layers, starting from the organic matter and down to the bedrock, which helps us to identify the parent material from which soils are formed. We all have seen different colors of soil. I was amazed in Andhra Pradesh, where you go, there is a soil which is red on one side and which is black on the other side. And both these soils have different properties in terms of growth and how it affects the composition in terms of chemistry, biology, or physics for plant growth and sustainability. I like to use it and try to connect the concept of soil with absorption of water. I like to use this example. When you scrub dishes in your home, and like in your dorms or wherever you live, we usually like try to soak water first, which takes a while, right? When you put water on the dishwashing material, it basically runs off. That is how the soil goes on. When you are putting some water, water runs off based upon how you are putting it up, whether it's tilted or not. So based upon, I compared that with elevation. It takes some time and water gets absorbed into the material. So that is how the process of irrigation or soil water pores are filled in as we apply water to it. And that's what we see in irrigated lands. Now, a lot of you might be thinking why I am talking all about soils when the topic was sensor technology for curbing global warming. So I'll tell that to you in a minute. Before we go into that, I want to highlight about the concerns in population. My talk will not be focusing on any aspects of population details. We all are aware of the fact how drastically our population have increased since the past years. And since until 2050, there is going to be an exponential growth in population across the world. Arable land is kind of, we are increasing, but not at a rate at which our population is increasing. When we contrast between developed and developing countries, there are different situations. But however, this is again a concerning solution because however amount of land we are having, that's not going to match the amount like population that we are going to reach in few years. So the big challenge is a lot of, at some point, if you hear about United States, in the Western United States, when I was in California doing my postdoc, my research was on drought because since 2014, which was the worst drought year in California, lots and lots of agricultural aspects of agricultural lands were impacted, global export and all the activities were impacted because of the drought. And we are still struggling, not only in California, but throughout the country, even in the wettest place of United States. Again, you might be hearing about drought. Recently, a couple months ago, California had flood warning. So in order to talk about all of these aspects of climate change, I do not talk in terms of one aspect, for example, drought, and let's just fight it. Flood, let's just fight it. I like to talk it about in terms of a resilient system or resilient agricultural practices, not just measuring 1, 2, or 3 data points, but measuring data on a spatial scale. So my lab here at Kansas State University, I recently started this position, and the way I'm designing my program is divided into different scales. I like to think this in a form of starting from a field scale, going to a farm, into a regional scale, and going to a watershed. When it goes beyond the watershed, I like to marry the two angles, which is the angle of policy and socio-economic aspect, and then the angle of science. The science part is done by us, scientists, researchers. And then when it comes to socio-economic aspect of it, we include growers, early adopters, stakeholders, and policy makers, where we integrate those activities of science with water rights cases. So basically, when we talk about any practices, be it saving water, nutrient, it is finally curbing down to carbon sequestration process, bringing down carbon, removing carbon from the atmosphere, storing it in the soils in order to restore ecosystems and reversing the global warming process. So that the problem with environmental aspect is, again, sequestering carbon that will help to stabilize climate and different weather pattern, biodiversity and soil health, re-establishing healthy water cycle, increasing the soil fertility and the quality of food that we produce under these constrained conditions, and bringing sustainability in our lives. Not going into details of carbon farming, but there are different processes. It could be, you might have heard about like management of grassland, jungles and forest regeneration, which is also termed as regenerative agriculture and permaculture. I recently published a paper on talking about the regenerative aspects and permaculture in agricultural scenario and how that could be tied about with the socioeconomic aspect of it. There are different, India, when I was I did my bachelor's from Shantiniketan from Vishwabharati University. And one of my projects was on system of rice intensification, West Bengal known for its rice cultivation. And that is what I was trying to work on a system that allows to grow rice with minimum addition of water. We do not stagnate the water for the whole time, but only for a limited period of time. So I talked about concerns, climate change, biodiversity loss, food security. And since you all are here, this is what you all think about and are aware about and want to learn about and be part of a challenge that allows us to curb global warming using different technology or optimizing different resources. So let's come down to understanding how sensing technologies work. I talked about soils, I talked about variabilities. When we look at the field, right? Usually when we are driving around a field, it's basically the growers are applying this. We feel like, okay, the same amount of irrigation might be applied. And in lots of like small farmers holding, not only in India, but I also realized when I came to the United States, small farmers or growers who are not early adopters are still applying the same amount of nutrient or same amount of nitrogen as a blanket in the whole field as recommended by the growers. But when I look into this field, I do see some variability. If you look into it, there are some patchy areas in the field. There are some darker areas. This is pivot irrigation, right? So I'm not sure what's going on, whether should I apply the same amount of irrigation or not. So I collect some soil samples, then collect your soil samples, homogenize it, send to the lab. So I collect 5 or 6 samples from the field, send it to the lab, get the estimation of nutrient or soil health parameters in my field. But again, that's dependent upon 5 or 6 samples, and then we are averaging it. But as a precision agriculture scientist, I do not like the term average. And that is why we try to estimate and sense different aspects of reflection, fluorescence, or many other chemometric techniques in the field to analyze the spatial variability. So basically, when I talk about precision agriculture, the definition could vary from person to person. And the way I like to talk it is, this is a definition that my students developed this semester, and every semester we have a different definition. So the most recent definition with people I'm working right now defines precision agriculture as technology, data-driven and innovative approach that is subfield to farm scale integrations, not for like a same pattern, but for homogeneous and profitable crop management practices for optimized productivity. Usually, we make a note of maximizing productivity, but here I want to identify the term optimize. We are not targeting to maximize the productivity, but optimize those production from the field. Whatever the capacity of the field is to generate the yield, we use technologies in order to produce any crop that is important to the region. Rice, wheat are some of the important crops across the globe. So this could include variable rate systems, aerial reflectance, and also integrating. I collaborate a lot with computer scientists and mechanical engineers. So we kind of build up and integrate technologies of artificial intelligence and sensing techniques. So this is just a replica. This is an artwork that was designed by one of my colleagues for the research field that I was working on. This was a processing tomato field. And my goal was to establish a decision support system. When I say decision support system, that means integrating wireless sensor networks, and all of those sensors are connected through the cell phone or through the web application that I might have. So I installed a sensor, for example, back in Montana, and I'm sitting in Kansas. So I can access the data that is released by those sensors on an hourly basis by sitting here and just monitoring what's going on. If there's a problem, if the sensor falls down, I get notification, and I can ask somebody in the farm to help get it back to place. So what you see here is 3 different aspects of sensors. And it is soil moisture sensor, canopy sensors, and also integration of drones. So what I use is soil probes. Let me show you a better picture in a minute. So this is based upon, first I'll talk about how I design. So basically I assess the variability across the field. I have instruments that allows us to work in different colorimetric spaces. When we talk about all of these sensors, this is what we see in a visible range that our eyes could see, in a range of 400 to 700 nanometers, which is a general notion. But when we talk about precision agriculture and sensing technologies, we work in many, many different ranges, which includes primarily my lab focuses on infrared radiations. I also have my PhD work was dependent upon ultraviolet and X-ray radiations. And there are many sensing technologies that we are working in different range that are from an atomic scale, molecular scale, or any different level as you can rise up to. So I brought this image from one of my research sites. So what I want to see here is in this image on X-axis in the graph, you see wavelength, and on Y-axis, you see reflectance. Not going into details of what reflectance means and all that. What is being reflected from the any object that you are seeing? For example, if you are seeing a color of a leaf, that means you are seeing green because all the green color is being reflected and the red and blue color are being absorbed. This is what I want to highlight on. If you see in this graph, the green is being reflected and red and blue are being absorbed. Comparatively, green is reflected more. That's why our eyes see the color green for any vegetative object that we are assessing. But when you go into the near infrared region, this is the near infrared region, the reflectance of green is way more than what our eyes could see. This is not the range what our eyes could see, but this is the range that sensors could assess. That is why when we talk about sensing technologies, we cannot just work on a visible range, but we have to move on to the near infrared regions. So my lab, this is an example of a drone imagery that I took, flew over a field. I had a multispectral camera. This multispectral camera has different band. It has visible range, red, green, blue. But what it also has is near infrared region of spectra that we are kind of calculating. When we measured those near infrared regions, we kind of stepped those colors up so that we can kind of analyze and visualize this. These are the 2 different stages where I took the images. In one stage, in the first figure, in the first imagery that we collected through drone, what you see here is 2 different varieties. One two on the ends, and the center variety is maturing at different rates. So we were able to know the different critical stage in crops where we have to irrigate now and which variety would need irrigation at some other time. Similarly, when the crop started senescing, or when the crop started to grow, like ready to harvest, it's not harvesting at the same time. So that's giving me an idea of which part of the field should I go and harvest first, or which part should I which part should be waiting more, so I can continue irrigating only for those rows and not for the whole field. So that saves me a lot and lot of water, a lot and lot of irrigation for managing fields when I use the sensing technologies. Another thing that I combine is thermal imagery to monitor crop water stress. Similar to multispectral camera, on the drone, I mount a thermal camera, which allows me to monitor the hot and cool spots of the field. So if you see this image, what you see here is the darker color of the fields are the cooler regions of the fields that the camera is detecting, and the lighter color is the hotter areas of the field. What I do is I identify those hotter areas, signifying the stress in the plants that are being accumulated. And the camera is kind of measuring and allowing us to estimate how much amount of water is needed to be applied and in what part of the field. So I'm not irrigating the whole field, but only that part of the field which is stressed. So that allows to save a lot of water. And this is how we develop irrigation decision support system. I talked about electrical conductivity. So there are devices that we use to measure, to map the field and the electrical conductivity in the field. The patchy growth definitely indicates the whole field is not the same. Therefore, you need to. When I talk about electrical conductivity, that means soils are charged particles. And I hope you all would agree with me. So those charged particles allows us to hold different nutrients, and that nutrients allows us to monitor the differences in properties of the soils in different parts of the field. So this is one of the one of my research fields that has different sensors. So these sensors are installed. This is one of my research site that are installed miles and miles away from where I'm sitting right now. It has soil moisture sensors, which is monitoring moisture at a lot of depths. And then I have canopy sensors, which has basically a camera under it, and the reflection by the crop is being calculated on the bottom of the camera. It's giving spectral reflectance. And based on that, I develop algorithms to manage water, nutrient, and other aspects, for example, disease, pest, and weeds in the field. So there's a concept of remote sensing, which includes satellites, drones you're remotely doing. And there's a concept of proximal sensing. When the object is in close proximity, that is what is called proximal sensing. And that's different from what we use the term remote sensing. So I use portable X-ray fluorescence spectrophotometer, Nixpro. These are some of the devices that I use to develop algorithms to measure soil iron and different elemental concentrations in soil on site. So this instrument particularly allows us to give 29 different elemental concentration in 90 seconds. Similarly, these are devices which I drove around the field and mapped the fields for electrical conductivity of the soil. That's my student monitoring the reflectance by the crop as it grows. And that's the instrument he has is Green Seeker, and that's allowing us to give the vegetative index or the health of the crop, whether it's deficient in nutrition or not. There are advances in robotics. I'm collaborating with a lot of robotic scientists and trying to develop techniques that we could integrate for non-human interventions in agricultural practices, and also kind of addressing the fact there's labor shortage all across the globe. So I want to conclude this presentation with a thought. Having a background of soil scientist, I think soils for life is the motto that we all should follow. And we need to understand, like, there's lots and lots of variability across the soil, and we need to estimate and sense those variabilities in order to produce our food. So with that, I stand for any questions, and thank you so much.
Yeah, Dr. Gaurav, that was a wonderful session that you have taken. I may not have been able to catch, every slide that you presented, but then nevertheless, whatever I could catch was absolutely interesting.
Thank you. And like honestly, like each slide could probably be a talk in itself. So
Exactly. Yes, absolutely. I agree to that. So in a country like US, which is a developed country, the country can afford to do these experiments and for miles together. So were you being able to have a little bit study done, or have a little bit understanding of what's happening in India, like?
right. So for that reason, like I'm initiating some collaborations with researchers in India. I have some publications with IIT Kharagpur, and then right now in my lab, I have two students who came from India. They are visiting scholars, and actually there is a master student who is coming from India in January who will be joining my lab. So there is a lot of exchange collaborations, and the student has been working with me for the last 1.5 years. So that's how we are trying to integrate and bridge like collaborations. Particularly in Kansas State University, there is a big program in India called NAHIT, and that's the initiative between US and India to identify issues that could be. And one of the things that I particularly work on is adoptions of these technology for small farm. uh, I showed an instrument which was a diamond shaped instrument, kind of. That's a very cheap instrument. And I'm using that to initiate or estimate soil health properties that could be integrated for nutrient management practices in different situations.
So the instrument which you showed, the one which you said, the diamond shaped instrument, would that be affordable by an Indian farmer also?
Yeah. So basically, what I used, it was like literally $300 for United States. But there is a cheaper version, less than $100 in India. So that is much more affordable. And if you're buying it, it's more of a visible range. So I would not say it's giving you what you would get in the laboratory. Definitely, those are gold standard research results when you send the sample to lab. But at least you get an idea in a range, what kind of range your soil organic matter or what or nutrient would be available. So those things are included in there.
In the experiments which you showed during your talk, it was more of use of drones and basically the sensors being attached to the drones, and that's how you were able to capture those videos. Was it that way mostly, like?
So my lab, right now, the way I'm developing my program, it's definitely on spatial scale. So one of the things with precision agriculture, my goal was to show about soil was it's the fields are variable. Like even from one part of the field to the other part, when you go, it's totally different. So that is the whole scale to understand on a spatial scale. But then you cannot fly a drone every day, or you cannot afford a drone every day, right? It could be expensive. So either integrating with satellite imagery, and one of my students, her project is basically to, we have drone images on a bi-weekly basis. For example, week 1, and then we take another image after week 2, but we do not know what is going to happen after that. So we kind of use machine learning there, knowing what we have, and then using the sensors. Like, for example, if you go to Google, you know what the weather will be like tomorrow. So we use all those information for predicting the imagery that would be available. So we are trying to develop some of those techniques, and a lot of research is going on in that area.
One of the drawbacks that we understand when we try to see how soil organic carbon can be measured is the amount of time span which is spent for a field which is having low soil organic carbon SOC to the stage where this increases. So there's a big gap. I would say at least some 3 to 6 months. So does this become a challenge when we are?
Right. So this is what precision, not just organic matter, even if soil pH, if you want to know, you have to collect samples, send to the lab, and it takes a lot of time, right? Any nutrition analysis. So with precision agriculture technologies, this is what we are trying to do, like developing algorithms and have in situ estimation. So believe me, right, like I'm working on a proposal, and this is what we are trying to do, identifying sensors that can assess soil texture immediately in the field, and we can map it out, identifying soil organic matter, and then tying it to weed herbicide resistance aspect. So there are sensors, but again, any sensor, when I talk to you, I cannot just tell you, oh, yeah, go ahead and use it. It has to be validated. For example, algorithms I develop in Kansas would not be applicable in California, would not be applicable in New Delhi, or would not be applicable in like Kerala or anywhere. So you have to have like site specific validation of those sensors. And that's where like universities, researchers, students play a big role in getting those. And our goal with Exchange Scholars is that's what we want to do. We want to train them with some of these technologies when they go back to India, if it's working in that conditions or not. That's what will bring up more ideas of development globally.
Okay, I won't take much of the time. Just one last question. Understanding the amount of rigorous efforts that's happening not just in US but all across the globe, because it's being already predicted, or it's being told, on a very serious note, that 2030 is the deadline that's been given to all the nations and everybody who stays on this earth. If we don't stabilize the global warming temperatures by 2030, it's going to be devastating. So this work of basically what you all are doing is carbon sequestration, trying to absorb the carbon by understanding the quality of the soil and improving the quality. So how do you feel, what is your understanding that this is going to help us to reach the goal of 2030?
I mean,
how far?
Honestly, like it would be hard for me to say any strong like deadline and things that we are doing, but there have been great efforts. Like there's a like it's not just scientists doing it, but it's like growers. All the proposals that USDA, which is one of the biggest funding agencies in the United States for growers, one of the big conditions for those getting those grants, you have to have on-farm partnerships, and that is what most of the researchers are doing. So not just research, it's not just like having a greenhouse or a research farm, but most of the researchers in Kansas State or other universities I have attended, we work on-farm research partnerships. And also in India, there is a big initiative, I understand, on adoption of drones in different areas. There are different challenges for it, but I mean, definitely there are government policies that are trying to promote these areas. So I would say it's not impossible, but definitely more widespread approach has to be done. And that will come from collaborative efforts that we make.
Right. Thank you. Thank you so very much, Dr. Gaurav. It was a wonderful session and a nice conversation. Dr. Padma, over to you.
I request the faculty members, if the students have any questions, please put it in the chat box. Any questions?
My email, if anyone wants to have a chat or anything, and
Yeah. Anyone, any question, faculty members or students related to today's session? I hope, sir, no questions, because ma'am has already
those are really good questions. And
yeah, ma'am has already asked so many questions, and almost all our questions answer we got it. Uh, I hope, sir, it was really a very wonderful session, and it was very informative and helpful. So like we all like technical background, so how we can use that, like machine learning or different programming techniques in the agriculture field for precision agriculture, that definitely help our student as well, and we will use it. And if any query comes, definitely we will connect to you.
for sure, yeah. And I'm on LinkedIn or Twitter. Feel free to connect. And if you have any questions and would like to discuss, feel free to email it to me, and I'll be happy to talk about it. But yeah, thank you so much again for inviting, and this was great.
Yeah, so we are
Talking to
looking
you.
many more sessions in future also,
For
because
sure.
it was
Thank you.
really good. Yeah, thank you.
All right. Thank you.